In this presentation on sets, we are going to talk about subsets and power set. We start this presentation with an example where we are considering two sets. One is the set A and another set we have it is B. Suppose we are representing these sets in this way. We are talking about this jar. It is representing the set A and it contains the elements 2, 3 and 5. We have another jar which is representing this set B and it contains the elements. This is the set B, this is representing the set B and it contains element 2, 3, 5, 7, 9. Now we can see that for the first element of this set A, it is 2. We are talking about, look at this condition over here. We have an element 2 over here. This element is also present in B. We are saying that 2 belongs to A and 2 belongs to B. For the second element of A, we are saying 3 belongs to A and 3 belongs to B. We are saying 5 belongs to A and 5 belongs to B. So what we can see over here is that every element of A is an element of B. So whenever we have this kind of situation that every element of the set A is an element of B, then we say that set A is a subset of set B and we write it in this form. This is the notation for subset. Now this situation we can also see in this way. We can also look at this situation in this way. Suppose we are saying this is the set A we are talking about. Then it has the elements 2, 3, 5. We are saying we have the set B. The elements 2, 3, 5, they are in set B. They are already in set B because all elements of A are in set B. And apart from 2, 3, 5, there are elements 7 and 9 which are also present in B. So this kind of situation we are saying it is representing that A is a subset of B. And in this same case, we also name this situation as, we are saying if A is a subset of B, we are talking about this condition, then B is called the superset of A. We are talking about the same condition. We are saying when A is a subset of B, then B is called the superset of A and we write it in this form. So we are saying if we are using this kind of notation, it is representing A is a subset of B. When we are using this representation, we are saying B is a superset of A. Both these things, when we are saying A is a subset of B or B is a superset of A, they are representing the same situation. Now the next term we have over here, it is proper subset. So we are saying if A is a subset of B, we have two sets A and B and A is a subset of B. And further we have the condition that A and B, they are not equal to each other. Then we are saying that A is called a proper subset of B. And this thing we can represent it in this way. This is the notation over here. So if we look at the examples, we are saying natural number, the set of natural numbers, it is a proper subset of whole numbers. Because we have the whole number 0, which is not a natural number. So these two sets, they are not equal. But natural number, the set of natural number is a subset of whole numbers. The set of whole numbers is a proper subset of integers. Set of integers is a proper subset of rational numbers. And set of rational numbers is a proper subset of real numbers. Now, if we are having the condition that a set is not a subset of another set, we look at an example over here. We are saying suppose A is equal to set 1, 2 and we are talking about B is equal to 2, 3 and 5. So again look at this condition over here. We are saying we have the set A, we have the set B. We are talking about these two sets. This is set A and this is set B. Set A contains the elements 1, 2. Set B contains elements 2, 3, 5. So we can look at this situation in this way. We are saying that we have the element 1 over here in A. We have this element 2 in A. Further, this 2 is also present in B. It is clear over here that this element 2 we are saying it is present in B also. Further, B has the elements 2 and 3. So clearly we can see from this that A is not a subset of B, because A has an element 1 which is not present in B, and B is not a subset of A because it has elements 3 and 5 which are not present in A. So what we have obtained from this is, we are saying that 1 belongs to A but 1 does not belong to B. So this implies us that A is not a subset of B. This is notation for proper subset, so we read it like A is not a proper subset of B. Second, we are saying 3 does not belong to B but 3 belongs to A. So we are saying that B is not a proper subset of A. Now next we have certain statements which we have to tell whether they are true or false. So the first statement is, this set is given, it has two elements A and E, and the statement says that this set AE is a subset of a set X where X is a vowel in the English alphabet. So if we list the vowels in the English alphabet, they are A, E, I, O, U, and clearly we have this element, first element over here we have it is A. It has two elements. We have to check whether A is present in this set. We are saying A belongs to this set. Next element we have it is E. So we are saying E also belongs to this set. It means that this statement it is true. Next example we have is, this set is given, it is X is it has elements X where X is a whole number and X plus 5 is equal to 5, and it is given that this is equal to empty set. So if we look at this set, we are saying X plus 5 is equal to 5. The solution we have it is X is equal to 0, and clearly it is a whole number. It means that this set contains an element, it consists of an element, that is the number 0. So we are saying that this set is not an empty set. So this statement that we have over here, it is false. Now the next statement that is given to us, it is, we are saying we have to check whether this statement is true or false. So we are talking about A belongs to the set ABC. So when we are talking about this set ABC, in this case we are saying, we are talking about a jar. It contains the elements A, B, C. So what we obtain is that there is an element A in this set. Next statement we have it is, we have to verify it is. So this previous statement it is true. Next statement we have is that set A, it belongs to the set A, B, C. So when we are talking about set A, it means we are talking about, we have a jar, it contains an element A. So this jar, it is representing set A, and there is no such element, we are talking about this element, there is no such element in this set. So we are saying that when we are saying that set A belongs to the set ABC, this statement it is false. So this will be more clear to you with our next example. We are saying the next we have is that set A, it belongs to the set containing the set A, then B, then C. So in this case, what kind of situation we have is, we are saying we have a jar, it now contains the set A. It contains the set A means that there is another jar inside this jar, and we have an element A inside this new jar, and further we have two more elements B and C. So we are saying that this situation, that a set contains the set A, then it has elements B and C. It is in this way, we can show this situation in this way. So we are saying that this jar, it is representing the set containing the set A, then B and C. So you can compare these two situations. We are talking about one situation, we have this, where we are saying this is the set ABC, And second situation we have in this form where we are saying the set contains the element A, then B, then C. So from this, what we can see, in this case we are saying that there is the element of this set, it is a set. So this statement we are saying it is true, that is A belongs to the set containing the set A, then B, and then C. Now next we have is set A, it is a subset of the set A, B, C. So when we are talking about this condition of subset, it means what we have to check. We are talking about this set A. Look at this condition over here. We are talking about this is the set. And we can see that this set has an element A which is present in this set A, B, C. We are saying this set has an element A which is present in this set. So it means that this statement it is true. Next we have is, the next statement we have is that A is a subset of ABC. When we are writing A over here, it means we are talking about the element A. But first condition for subset that we have is that A should be a set. We should have a set over here. So it means that there is no meaning of this term when we are saying that element A is a subset of the set ABC. I am again explaining this situation. We are saying we have element A is a subset of A, B, C, of the set containing elements A, B, C. So there is no meaning of this term because whenever we are talking about subset, both these should be sets. But in this case, this is not a set, this is an element that we have. So we are saying that this statement it is false. Next statement we have is we are talking about set A and we are saying it is a subset of the set containing the elements. It has element A, B, and C. Now in this case what we can say is, what we have to prove is we are talking about this set A is there. This set has an element A, but this element is not present in this second set, because when we are talking about this second set, it has the set containing the element A, whereas it does not has the element A itself over here. So we are saying that this statement we have it is false. Now the next statement we have, it is phi is a subset of A, B, C. So when we are talking about this set phi, it is the empty set we are saying, and we are representing it over here. This is the empty set, and we are talking about the set ABC. So when we are saying ABC, this is the set ABC. So over here what we can say is that there is no element in phi. There is no element in this set phi. It is empty. So we are saying there is no element in phi which is not present in the set ABC. So we are saying that phi is a subset of ABC. So this statement it is true. The second we have is the set containing phi is a subset of ABC. So when we are talking about the set containing phi, we are saying we have these conditions over here. We are having the jar, and this is the set containing the set phi. We are talking about this situation. We are saying this is the empty set. We are considering a set and it contains a set which is empty. So these two sets, these are representing the different things. I hope this is clear to you that this set and this set, they are representing two different things. Now when we are talking about this second set, we are saying there is an element in this set which is empty. We are saying there is an element in this set which is empty. So we are saying that phi belongs to the set containing the empty set, but phi it does not belong to the set A, B, C. So we are saying that this statement that is given over here, it is false. Now, if we have to correct this statement, what we have to do? We are saying, suppose we are considering a jar, and this jar contains the empty set. This jar contains the empty set, as well as it has the elements A, B, C. So how we are going to represent this set? We are going to write that we have a set which contains the element phi. It has an empty set in it. Further, it has the elements A, B, and C in it. So we are saying the correct statement corresponding to it will be that set phi is a subset of this set which contains the element phi. It contains the element A, B, and C. Now the next question we have is, let we have a set A that is equal to 1. It contains a element which is a set 2. It contains the element which is the set 3, 4, and it contains the element 5. We have to tell which of these conditions they are true. So first of all, we are saying it contains how many elements? It contains 4 elements. The elements in this set, they are 1, then there is an element 2, then there is an element 3, 4, and then there is an element 5. So we can look at this situation in this way. We are talking about the set. It contains the elements. We are saying it contains in 2 sets. In one set we have the element 2 is there. In another set we have the element 3, 4 is there, and further it has the elements 1 and 5. So this is the set A we are talking over here. Now the first statement we have is 2 belongs to A. So it is clear over here that 2 does not belong to A, but it is this jar containing the 2 which belongs to A. So we are saying this statement it is incorrect, and the correct statement will be, if we have to correct this statement, then it would be, we are saying the set 2 it belongs to A. When we are saying set 2, it means we are talking about this jar which is containing the element 2. Next is set 2 is a subset of A. So when we are saying set 2 is a subset of A, it means we have to prove that the set 2 it contains the element 2 which should be present in A. By the definition we have the definition of subset, we are saying that 2 belongs to the set 2, but 2 does not belong to, it does not belong to set A. So we are saying this implies us that the set 2 is not a subset of A. So we are saying that this statement we have over here, it is incorrect. This statement is incorrect. And the correct statement would be, we are saying the set 2, we are talking about the set containing the set 2 is a subset of A. So in this case what we will have is, when we are talking about this case, we are saying we have set 2, it belongs to the set containing 2, and this set 2 it also belongs to A. So we are saying that this statement will be true. Next is set containing the elements 1 and 2 is a subset of A. So again we have 2 does not belong to A. It has an element 2 over here, and it does not belong to A. So we are saying that this statement it is incorrect. So if we have to correct this statement, the correct statement would be, we are saying it has element 1 and then the next element is the set 2. We are saying this is a subset of A. Then this is the correct statement. Next is the set 1, 5 is a subset of A. So clearly we have, in this case, we are saying that 1 belongs to A, and we have 1 belongs to the set 1 comma 5, and 1 belongs to A. Further we have 5 belongs to the set 1 comma 5, and 5 belongs to A. So what we are saying, that both the elements of this set, they are present in the set A. So we have this statement, it is correct. This statement is correct because 1 and 5 both are elements of A. The next statement is the set containing the element 5. It is a subset of A. So again, looking at this situation, we are talking about this situation over here. So we are saying that phi is an element of this set. We are talking about this set. We are saying phi is an element of this set, but phi does not belong to A. It means this statement, it is incorrect. Next is phi is a subset of A. So when we are writing phi is a subset of A, again we are giving the same reason, that this empty set does not have any element which is not contained in A. It means that phi is a subset of A. So we are saying that this statement, it is correct. Next is 1 is a subset of A. So in this case we are saying this statement, it is incorrect, because when we are talking about, this is the element 1 or number, this 1 we are treating it as a number. So we are saying that 1 is not a set, so it can't be a subset. So the correct statement will be, either we have to write 1 belongs to A, the element 1, it belongs to A, or we have to write this set 1, it is a subset of A. So either we have to write this statement in this form, or we have to write it in this form. Next is the set 1, 2, 3, 4 is a subset of A. So this is the next statement we have. So we are saying, again we have the element 2 in this set. We are talking about 1, 2, 3, 4. This set contains an element 2, and this 2, it does not belong to the set A, because the set A, in the set A we have the set which contains the element 2. Similarly, we are saying that 3 does not belong to A. So what we have is that this statement, it is incorrect. So we are saying the correct statement in this case, that would be that this set containing 1, then set containing 2, then the set containing the elements 3, 4. This set is a subset of A, because in this case every element that we have over here, we are saying 1 belongs to this set and 1 belongs to A. We are talking about this element, we are saying set 2, it belongs to the set containing 1, 2, 3, 4, and this 2 also belongs to A. And similarly this set 3, 4, it belongs to this set as well as to the set A. So the correct statement would be in this form. Now the next statement we have, it is, if A is a subset of B and X does not belong to B, then we have to tell whether X does not belong to A. This statement, it is true or false. So we are considering this situation in this way. We are saying we have, this is the set A and it is the subset of set B. Every element of A is the element of B. We are saying that there is an element X which is not present in B. So we are talking about an element X which is not present in this set B. Then clearly this element, it cannot be present in this set A. So we are saying that this given statement, it is true. Next we have is, the next statement we have is, if A is a subset of phi then A is equal to 5. So the proof of this statement we will give in our next slides. So we can just understand this thing, that this statement it is true. Why? Because we are saying an empty set is a subset of every set. This thing we have already seen in our previous slide, some examples we have seen. And further we are saying that the empty set is a subset of itself. We are saying that empty set is a subset of every set. It means empty set is a subset of itself, and moreover we have that only subset of empty set is the empty set. So we will look at the proof of these statements in our next slides. Now next we have to prove that the following statements they are false. So first is, if A, B and C are the three sets such that A belongs to B and B is a subset of C, then we have A is a subset of C. We have to prove that this statement it is false. So suppose I am considering the set A as, we are considering that set A has one element, it is A. So we can look at this situation in this way, that A has the element A. We are considering the set B. We have to disprove this statement. So we are going to give an example to show that this thing is not always true. Now B has elements. It contains the set A and it has the element B. And we are considering another set C. And that set we are saying it is in this form, that it contains the set A and further it contains the elements B and C. So clearly what we have in this case is that A belongs to B. We have this is the set A and it is present in this set B. So this statement A belongs to B is true. We are saying B is a subset of C. So B is a subset of C because B has an element A, it is present in this set C. B has an element B which is present in this set C. Now we are talking about A is a subset of C. So what we have is, in this case, what we are saying that A is a subset of C means we are talking about that A belongs to A. This set A, it contains an element A, but there is no element A in the set C, because we are saying the set A it belongs to C. We are saying this thing. So we have this statement, it is false. Next is, if A, B and C are the three sets such that A is a subset of B and B belongs to C, then we are saying that A belongs to C. We have to disprove this statement. So we are going to give the examples over here. So in this case we are considering that the set A it is A. Set A contains the element, it is A. Then we are talking about the set B. Suppose the B we are considering it consists of the elements A, B. We are talking about the situation in this form. It contains the elements A, B. And the set C we are saying it has elements containing the set containing element A, B and another element C. So it is just like the situation in this form. Now first of all we are talking about the condition that A is a subset of B. When we are saying A is a subset of B, so A has an element A which belongs to A, and we have A also belongs to B. So we are saying that A is a subset of B, and it is proper subset because B belongs to B, but B does not belong to A. It means that set A is not equal to B. So we are saying that A is a proper subset of B. Now further we have B belongs to C. So B belongs to C means there is the set B, it is having this element A, B, and it is present over here in this set. We can look at it like this, that this jar, this complete jar is present over here as A, B. So we have B belongs to C. Then we are saying A belongs to C. But we can see over here that there is, when we are talking about this A is representing this complete jar. And this jar containing the element A is not present over here. There is no jar in this way. We are saying this jar we are having, this is representing the set B. Now, if we are saying A belongs to C, it means we are talking about the situation that this jar, it should be present over here. This jar should be present over here in this set C. Then we will have, this statement would have been true, but this jar is not present over here. So we are saying that this statement, it is false. So we have given this particular example to show that this statement, it does not hold for all A, B and C. Next we have is, if A, B, C are three sets such that A is not a subset of B, B is not a subset of C, then A is not a subset of C. So we are considering three sets over here. One set we are saying it is containing the element A. So we are talking about this set A, it contains the element A. Then we are talking about another set, say B, it contains the elements B, C. We are talking about, this is a set B, it contains the elements B, C. So clearly we have A is not a subset of B, because we have an element A belonging to A, but A does not belong to B. So we are saying that A is not a subset of B. Now next, third thing we are considering over here, it is the third set we are considering over here, it is this set C, it contains the elements AC. So we are saying that B is not a subset of C, because B has an element, we have an element B belonging to B, and B does not belong to C. So we have B is not a subset of C. And further we are saying that A is not a subset of C. But what we see over here is, that A belongs to A. A has only one element A, and A belongs to the set C. So what we obtain from this is that A is a subset of C, and further it is proper subset of C in this case. So we are saying that this statement, it is false. Now next we have is, if A and B are sets such that X belongs to A and A belongs to B, then we are saying that X belongs to B. We have to disprove this statement. So we are considering, let the set X be A be the set containing the element X, and B is the set containing the elements, it has the set X and Y. So we can look at this situation in this way. We are saying we have, this is the set A that we have, and this is the set B. We are saying it contains the element set X and another element Y over here. So we are saying what we have over here, that X belongs to A. It is clear over here that X belongs to this set A. We have A belongs to B. This set A is present in this B. Then we are saying X does not belong to B. There is no element B in this set, but it is the set A that is present over here. So we are saying that this statement, it is false. Now next we have some results on subsets. So first result we have is that every set is a subset of itself. The proof is quite simple. We are saying let A be any set. So clearly every element of A will be element of itself. So by the definition of subset, we are saying that A is a subset of A. It is important to note over here, we are using this term subset. We are not saying proper subset, because A is not a proper subset of itself, but it is a subset of itself. Next we have is, the empty set is a subset of every set. So the proof we have over here, it is, we are saying let A be any set and phi be the empty set. Now phi contains no element. There is no element in the empty set. So we are saying that there is no element of phi which is not contained in A, and hence we can say that phi is a subset of A. Now next term we have, it is universal set. So suppose we are saying that a set is given, or a collection of sets is given, and we write another set that is superset of all the given sets. We are talking about is another set which is superset of all these given sets. Then that new set we have found, that is superset of the given sets, that is called the universal set. So we explain this with an example. Suppose we are saying we have three sets A, B and C. A has elements 1, 2, 3, B has elements 2, 3, 4, 5, C has elements 6 and 7. So we have to, if we have to find the superset of this set, or universal set corresponding to these three sets, so we are trying to find a set which is superset for all these three sets. So we are writing it in this way. We are writing it as 1, 2, 3, 4, 5, 6, 7. This collection we are writing. We are representing it with U. So this U is the superset of A, U is superset of B, U is superset of C. So we are saying that this set U is the universal set for these sets. Further, suppose I am talking about the set N of natural numbers. It is also the universal set for these sets. If I am talking about the set of rational numbers, integers, real numbers, so all these sets, these are the universal set for these sets. So another example we can say that when we are talking about the set of lines, when we are talking about the set of lines, we are talking about triangles, we are talking about circles in 2 dimensions. Then the plane in which these lies, we are talking about the plane in which these lines, triangles and circle they lie, that may be considered as the universal set corresponding to the set of lines, set of triangles or set of circles. Next we have the equal sets. So we are saying that two sets A and B are said to be equal if every element of A is in B and every element of B is in A, and we write A is equal to B. So what we mean to say over here is that if we have to prove that two sets A and B they are equal, then this is equivalent to proving the statement that every element of A is element of B, that is A is a subset of B. And if we prove that B is a subset of A, we are saying every element of B, A is element of B and every element of B is element of A, then we are saying that both these sets they are equal. The next term we have, it is power set. So it is defined like the set of all subsets of a given set A. It is called the power set of A, and we denote the power set by P of A. Now if we have to count the number of elements in the power set, we are saying, we have a theorem over here, that the total number of subsets of a set containing n elements is 2 raised to the power n. So the number of elements in the power set in P of A, that is 2 raised to the power n, if the given set A has n elements. So we are going to give the proof over here. The proof is based upon binomial theorem, so you can skip at this moment. So the proof is, let A be a finite set containing n elements. The given set we have, it contains n elements. Then number of subsets of A, each containing no element. We are talking about those subsets of A which contain no element. So that will be given by, we are saying we have n elements and we are choosing no element out of it. So the value we have, that is equal to 1. Next, number of subsets of A, each containing one element. It means out of the n elements, now we are choosing one element. So there are n C1 ways. Then number of subsets of A containing two elements. It means we are choosing two elements out of these n elements. So it is nC2. Likewise, if we continue, we are saying the number of subsets of A each containing n elements. So we are saying there are n Cn ways. So total number of ways, it means it will have the power set, it will have the sets containing no element, one element, two element, then n elements. So the total number of ways will be the sum of all these terms. It is C0 plus nc1 plus nc2 plus so on up to ncn. And we know that from binomial theorem, using the binomial theorem, we know that this is the expansion for 1 plus 1 raised to the power n. So the answer we obtain, it is 2 raised to the power n. So we are saying that the total number of subsets of a set containing n elements is 2 raised to the power n. Next we have to write the all possible subsets of. So the set given, it is 4. So we have to write the power set. We are writing it in this way, it is P of A. So the set containing no element, it is 5. We are saying this is a subset which contains no element. Then the subset containing one element, it is 4 itself. So the power set of this set 4, it is this set PA. Next we have the set B. It has two elements, 2 and 3. We have to write the power sets over here. So the number of elements in the power set, that will be given by 2 raised to the power 2, that is equal to 4. So how we are going to write those elements? We are saying power set of B. First of all, it contains the empty set, that is set containing no element. Then this power set has those sets which contain one element. We are saying one element means this set contains element 2. Then this set contains element 3. These are the sets having only one element. Then we have the set containing two elements, that is 2, 3. Next we have is the set C. We are saying it has elements 1 and it has element the set 2, 3. So number of elements in this set C, it is 2. So the elements we have over here, it is 1, and the second element we have, it is 2, 3. So in power set of this set C, we will have the elements. First of all, we will have the empty set. Then we have the sets containing one element. Then we have another set containing one element. So it is important to note over here that this is the set which contains one element. That element itself, it is a set which further contains two elements. So next we have to write the set which contains both the two elements, both the elements of this set C. So we are saying this is the power set of C. Next is the set D is given. Then we know that phi has only subset, it has only subset phi. So we are saying that the power set of phi is equal to the set containing the element phi. Why? We are saying the number of elements in D, that is equal to 0. So number of elements in power set of D, that is 2 raised to the power 0, is equal to 1. So we are saying that this set, it contains the element, that is the empty set. This set is given, A is containing the elements A, B, C. So there are 3 elements, and we have to write the powers. We have to write the power set of A and number of elements in the power set of A. So we have number of elements in the power set of A, that will be equal to 2 raised to the power 3, 2 raised to the power n. N over here, it is 3, because this set has 3 elements A, B and C. So we are saying that total number of elements in power set of A, that will be 8. Now how we are going to list those elements? We are saying first of all, we are listing the element. We are listing the set without any element, it is 5. Then we have the set which consists of only one element. One element means we are talking about, we have element A, B and C. So we have 3 elements over here, the set containing element A, set containing element B and set containing element C. Then we have the sets containing 2 elements. We have to choose 2 elements from this. So first we are choosing A and B. We can choose A and C. we can choose B and C. And last, we have to choose all the three elements together. So it is A, B and C. So this is the power set of the set A containing the elements A, B, C.